There we go. So the first thing we're looking at are these properties here with roots. Now we kind of talked about this here with fractional exponents, not just having 1 over n, but actually having an exponent. We called it x yesterday, or we can call it m. So if we say a is to the m over n, we can really rewrite it as the nth root of a to the m. And this here, doing this, makes it easier to simplify. And we'll see that here in a minute. Now a to the negative m over n, we can make the exponent positive by taking it from the numerator to the denominator, top to the bottom, changes the sign of the exponent. Then do essentially the exact same thing and simplify it from here. So let's actually get an example of looking at this. So the first one we have is 16 to the 3/2. Now according to our property, a to the m over n is the same as the nth root of a to the m. And for us here, a in this case is 16. M is 3 and n is 2. So what we could say is that 16 to the 3/2 is the same as 16 inside the radical. Our index is 2 and our m is 3. So visually trying to see what 16 to the 3/2 is going to be a little challenging. But if we rewrite it as the square root of 16 to the 3rd, well, the square root of 16 is 4. And now we just need to take 4 to the 3rd. Well, 16, 4 squared is 16. We just need to multiply it by 4 one more time. 4, carry the 2. 4 times 1 is 4, plus 2 is 6. Yes, or we could say 16 plus 16 is 32, and 32 plus 32 is 64. Because 16 times 2 is 32. Then we need to multiply one more 2 to get to 64.
That water fountain tastes better than I want to add.
Did you have the one outside of Cherry's? Yeah. Yeah. If you see any of them that don't have the filter gauge on it, it doesn't have a filter. Oh. Yep. Let's look at B. 32 to the negative 3/5. Well, according to our formula, a to the negative m over n, if we work it out, we end up getting the same as 1 over the 1 over the nth root of a to the m.
How do we know what our a m is?
So here, a would be m. So we're just going to say 3, and n is 5. Because we don't have to worry about the negative, since in the formula, the negative isn't moving down to the bottom of the fraction. So when we set it up, we have 1 over nth root, so we'll have the 5th root of 32 to the 3rd. Now the question is what is the 5th root of 32? It is indeed 2. Now one way we can do this is, let's get, we can take 32 and we can do a factor tree. And that's just rewriting it as prime factors. So we can say 2 times 16. Well, 16 is 2 times 8 is 2 times. And it works out the prime factorization. We have 1, 2, 3, 4, 5. So this is the same as 2 to the 5th. So the 5th root of 32 is 2. Now we just need to take 2 cubed. And 2 cubed is? So it is 1/8. Clear. Now in the graphing calculator, the first one we had was 16 to the 3/2. And we could do it in the calculator and get 64. We could do 32 to the -3/5. But this time it gives us 0.125. But we can go math, enter, enter, and it does give us 1/8. So it does work. We could do it in the 30xs. We can do it in either calculator, and it would give us an answer. And the reason that this works is because, well, for the first one, we can take the square root of 16. Here, we can take the 5th root of 32. We can take the 5th root, the square root of these numbers, and we get a nice number. Because if they're asking us to leave it in radical form, we need to be able to simplify those. So we'll look at this next one here. 9 to the 1/5. We can type it in as 9 to the 1/5. Okay. But really we're saying we're taking the 5th root of 9. Now is there a number that we can multiply by itself 5 times and get 9? No, it's not going to work because the smallest 5th root, the smallest positive number we can take the 5th root of is what? It's kind of a gimme. What's the smallest number we can take the 5th root of? 1. Because the 5th root of 1 is 1. The next one is, really it's 2 to the 5th, which is 32. So the number after 1 is 32. That's the smallest number we can take the 5th root of. So 9 to the 1/5 doesn't have a chance. But we can still find 9 to the 1/5, which is 1.55 if we round to the second decimal place. We get this here. And again, when plugging it in, we could do the division. I could have done 1 to the 1/5 as a fraction. We can do it in either way. A lot of the times, especially in the graphing calculator, I will use the division, not the actual alpha y equals enter. Because it's a lot faster to say 1 divided by 5 in the graphing calculator than to get the actual fraction. Math, enter, enter. If we can actually get it back to a fraction. 12 to the, what's that, 3/8. 2.54. And the last one, the 4th root of 7 cubed, we could type it in as this here. Now if I wrote it as a fractional exponent, how would we write this as a fractional exponent? What number would go on top? Because this is going back to our a to the m over n is equal to the nth root of a to the m. Yes. Which is 4.30. Questions on any of this here? Questions on any of this so far? All right. Solving equations using the nth root. Solving equations using the nth root. Now, we've done something similar to this before. Square root method. So y'all remember doing the square root method? It was last year. or in the fall semester. But when we had x squared equaled something, we got the x squared by itself, then we took the square root of both sides and solved from there. And even if we had a set of parentheses squared, we'd get it by itself, square root both sides, and solve. And we will do a similar method for this here. So we have 4x to the 5th equals 128. So the first thing we would do is get the variable by itself, and we would divide both sides by 4. And that will tell us x to the 5th is 32. Now, when we did the square root method, our next step would be to take the square root of both sides. But will the square root of x to the 5th simplify that? Well, no, that would just simplify x squared. So what do we need to take? We need to take the 5th root, because the 5th root of x to the 5th will be x. And the 5th root of 32 is 2. Do we need to say plus or minus 2? What root are we taking? Even or odd? Is it an even root or an odd root that we just applied? Fifth root is odd, so we only have one real root. Because when we take odd roots, we only have one real root. If we have taken even root, then we have 2. So here we only have 1 because we applied an odd root to both sides. If we applied an even root to both sides, then we need plus or minus. So here we just have 2. Now here the first thing we need to do is to get our set of parentheses by itself. Is it by itself? Well, yes. So now we can apply what root to both sides? 4th root. Because the 4th root and 4 will cancel. Notice that we have the 4th root of 21. Now, since it doesn't ask us to approximate, we can leave it as the 4th root of 21. But this time we do need the plus or minus because we're taking an even root of it. But since x is not by itself, we need 2. Add 3 to both sides, so this x is equal to 3 plus or minus the 4th root of 21. Questions on this here? Luckily, for the most part, this isn't anything new. We ready for the next one? All right. Now, with a problem like this here, again, 5x to the 3rd equals 320. The first thing we want to do is to get the x by itself. And we can do that by dividing both sides by 5. Then we need to take the so we won't square root, but we will cubed root both sides. Is the cubed root of x to the 3rd will cancel, telling us x is equal to is 4. Now, since we're taking an odd root, not an even root, we only have one answer. Questions on this here? Let's see here. Yeah. Let's look at this one here. Is our set of parentheses by itself?
No.
Well, yes,
Yes.
because we don't have anything added to it or multiplied in front of it, so we can go on and take the fourth root of both sides. These will minus x plus 5 is equal to plus or minus, because again, whenever we take an even root, we have to add the plus or minus. Now we need to take the fourth root of 16. Can we take the fourth root of 16? Two. Is the variable by itself?
Yes.
So we need 2
Subtract 5.
from both sides. Minus x is equal to negative 5 plus or minus 2.
Not being an original.
Can we add and subtract negative 5 and 2? Because what is negative 5 plus 2?
3.
Negative 3. Negative 5 minus 2 is so if we can simplify it, we're going to need to simplify it. But that's it. Questions on any of this here?
After you drink about 4 of the word,
So let's look at this one here. Now the parentheses are already by themselves, so we can take the cubed root of both sides. So these will minus x minus 2 is equal to cubed root of negative 14. Yeah. So can we take the cubed root of 14? No. And lastly, we can add 2 to both sides. Now, since it is an odd root, we don't have to put a plus or minus. Well, we don't put a plus or minus. So it doesn't matter where we add the 2. We can add it after the radical or before it. Either one works. So this here is the answer. Well, find the real solutions of the equation around your answer to 2 decimal places. So if we're going to round this, I always wait to the very end. So here, so we have the third root of negative 14 plus 2, which is negative 0.4. Negative 0.41. Yep, since we go 2 decimal places. And if we had the plus or minus, we would do the positive and negative case. So we've done 2 plus the cube, or the fourth root of negative 4th root of 14 minus it. Same exact thing. But that's it.